Good morning, students. We have studied about the chapter 12 electricity. First topic, electric current and electric circuit. Okay, we have seen what is the electric current, that is the net charge flowing per unit area per unit time, and what is its units, that is ampere. What is electric circuit, closed conducting path. Okay, then what is the flow of charge, what is the cause of this electric current, that is the flow of electrons, and this flow of electrons is caused by the creating potential difference across the 2 points of any conductor, okay, or electric circuit. So we have studied about the electric potential. So the potential difference is defined as the work done upon charge, and its unit is volt, and when we define 1 volt, that is 1 joule per coulomb. Next, we have learned about the different symbols of the components used in the electric circuit, that is electric cell, battery, plug key, wire joint, etc. Now we will discuss the Ohm's law. What is Ohm's law? Ohm's law is V directly proportional to I, okay, that is V is equal to IR. We have studied in the last class. That is, what is V? V is potential difference and I is current, and V upon I's ratio is constant, that is equal to R, that is the resistance of the circuit, and it is given by the scientist George Simon Ohm from 1787 to 1854. The relationship between the current and the potential difference is given. So V upon I is constant is equal to R, and V is equal to IR is the relation given by the Ohm's and said to be the Ohm's law. R is equal to V upon I is the resistance of the circuit, and its unit is ohm, and if the potential difference across the two ends of the conductor is 1 volt and the current through it is 1 ampere, then the resistance R of the conductor is 1 ohms. 1 ohm is equal to 1 volt upon 1 ampere, and that is I is equal to V upon R. Okay, and for regulating the variable or regulate the current without changing the voltage source, we can use the variable resistance in the circuit, and that variable resistance is used as the rheostat. Okay, so rheostat can be used for correcting the circuit current in the circuit. Okay, and motion of electrons in electric circuit constitutes an electric current, and these electrons, however, are not completely free to move within a conductor. They are restrained by attraction of atoms among which they move. Thus, motion of electrons through a conductor is retarded by its resistance. Every conductor having own resistance, that is, it resists the flow of electrons and offers a slow resistance. The conductors which offers a very low resistance is known as the good conductor, and the conductor which offers appreciable resistance or high resistance is known as the resistor, and the conductor or component of identical size that offers a very high resistance is known as the poor conductor. Factors on which the resistance of a conductor depends. The factor on which the resistance of the conductor depends on the length of the conductor and area of the cross section of the conductor. And on applying Ohm's law, we observed that resistance of the conductor depends on length and area of the conductor. Okay, on length it is directly proportional, and on area of cross section it is inversely proportional. And rho is a constant of proportionality and is called the electrical resistivity of the material, and its unit is ohm meter. Okay, the higher the resistivity, the higher is the current flow in the circuit. The metals allows a very high resistivity of 10 to the power minus 8 ohm meter to 10 to the power minus 6 ohm meter. Low resistivity offers higher current. Okay, so metal and alloys offers a very low resistivity of the range of 10 to the power minus 8 ohm meter to alloys having the resistivity 10 to the power minus 6 ohm meter, and they are good conductors of electricity. And insulators like rubber and glass have resistivity of the order of 10 to the power 12 and 10 to the power 17 ohm meter. Okay, tungsten There are different alloys which are used as heating devices for the same reason, because their electrical resistivity is very low, and the elements which have resistivity low have the conductivity very high, that is, they are good conductors of electric current. Okay, so in this example you can calculate the value of current. We have given here the current, how much current we have to calculate through a source of 220 volt battery if the resistance of the filament is 1200 ohms. Okay, so if the resistance is 1200 ohms, we can calculate the current by V upon I, that is the Ohm's law. And how much current will an heater will draw from a 220 volt source if the resistance of the heater coil is 100 ohms. So I is equal to 220 volt upon 100, that is 2.2 amperes. Potential difference between the terminals of an electric heater is 60 volt. Okay, so potential difference between the terminals of an electric heater is 60 volt, and when it draws a current of 4 ampere source, the current will be the heater drawn with the potential difference is increased to 120 volt. So R is equal to V upon I, that is equal to 15 ohms. Okay, so by Ohm's law we can solve these numericals, and if the length is given of the resistor and ohms also given here, okay, here at 20 degrees centigrade, if the diameter of the wire is 0.3 mm, diameter is given, so we can calculate the area of cross section. Okay, so area of cross section will be pi d square upon 4. Okay, so RA upon L, so RA upon L we can do here. RD square upon 4 is that is the pi R square. Okay, so pi R upon 2, that is D upon 2, that is R. Okay, so D upon 2 is the diameter upon half is the radius, that is pi R square. Okay, pi R square is the area of cross section, and pi R square into R upon L. So RA upon L is the area of cross section. We can calculate the resistivity of the given metallic wire. And wire having given length L and area of cross section A has a resistance 4 ohm. And what would be the resistance of another wire of the same material having length L by 2 and area of cross section 2 ampere? So whenever you put the value of L and resistance and the area of cross section, we can calculate the ratio of the resistance for the first and the second wire, R1 and R2. For the first wire, R1 is equal to rho L by A, that is 4 ohms is given, and for the second wire, R2 is rho into L by 2 upon 2A, that is L by 4 or L by 1 by 4 ohms. Okay, so R2 is equal to 1 ohms. The resistance of the new wire is equal to 1 ohms. Okay, by taking the ratio, the length is halved and area is doubled, so L by 2 and 2A we place here in place of length and area of cross section. By calculating the ratios, we get the ratio is 1 upon 4. Okay, and it is 1 upon 4, so R2 upon R1 is equal to 1 by 4. Okay, R2 is equal to 1 ohms. What is the resistance of systems of resistors is our next topic. Okay, so till this topic we have to do the different numericals given on the basis of the resistivity. Okay, so resistivity is rho L by A, and it is also given by the Ohm's law. Ohm's law and the numericals based on the resistivity we have to study till here. Okay, in the next class we will discuss about the combination of the resistance, that is the series combination and parallel combination, that is the resistance of a system of resistors. Okay, thank you, have a nice day.